Hi everyone, welcome to Python Code Nemesis. Today we'll be going through dependency injector design patterns in Python. Dependency injection is a design pattern that promotes loose coupling and modular code by allowing objects to be created with dependencies provided by an external source rather than the object itself. What are dependencies? In software engineering, dependencies refer to the relationships between different components or modules in a software system where a component or module relies on another function correctly. So, one of the component depends on some other component to function correctly. In the dependency injection design pattern context, dependencies refer specifically to the external objects or services where an object needs to function correctly. For example, a database connection object might depend on a database driver object, a configuration object, and a network connection object. Similarly, our Flask application might depend externally on several libraries which it might use for internal calculations. Types of dependencies. In general, dependencies can be classified into two types, direct and transitive. Direct dependencies. Direct dependencies are those that the component or module requires in order to function. Transitive dependencies are those that are required by a direct dependency. For example, consider a Python web application that uses the Flask framework. The Flask framework is a direct dependency of the application since the application requires Flask to function. However, Flask itself has transitive dependencies on other packages such as Jinja2 and Worksig, which are required for Flask to work correctly. These packages are transitive dependencies of the application since they are required by the direct dependency Flask of the application. Containers. Containers is the dependency injector library in Python are objects that serve as the external source for dependencies. They allow the configuration and management of dependencies and their life cycles. So they just make it working with different modules easier. In other words, a container is an object that holds and manages a collection of dependencies and provides methods for instantiating and injecting these dependencies into other objects. The dependency injector library provides a container that the class that is used to manage dependencies in a centralized way. What are the benefits of using containers? Using a container has several benefits. Centralized configuration. All dependencies can be configured in a single location, making managing and modifying them easy. Separation of concerns. The container separates the creation of dependencies from the objects that use them, allowing the objects to focus on their specific functionality without worrying about how the dependencies are created. Dependency reuse. The container can create singleton dependencies that are reused across multiple objects, reducing the overhead of creating and destroying dependencies. Testability. The container makes it easy to mock or substitute dependencies during testing, allowing for better test coverage and more reliable tests. In the dependency injector library, the app container manages the creation and configuration of the Flask application and the database object. By defining providers for these objects, we can easily modify their configuration and reuse them across different application paths. Using a container allows us to easily manage dependencies in a modular and flexible way, improving the overall maintainability and scalability of a software system. Container classes dependency injector. The dependency injector library in Python provides several container classes such as single container, singleton container, thread local container, and multi-container, each with different life cycles and management strategies for dependencies. Containers are a fundamental concept in the dependency injection design pattern, and they play a key role in enabling modularity, flexibility, and maintainability in code. Providers. In the dependency injection pattern context, a provider is a function or a callable object that creates and returns an instance of a dependency when it's called. Providers are a fundamental concept in the dependency injection pattern because they allow dependencies to be created dynamically and decouple the creation of dependencies from the objects that depend on them. In Python, the dependency injector library provides several types of providers that can be called to create and manage dependencies, such as factory, singleton, callable object, and more. For example, a singleton provider creates and returns a single instance of a dependency, ensuring the subsequent calls for the provider return the same instance. A factory provider creates a new instance of a dependency each time it's called. A callable provider calls a user-defined function to create the dependency. An object provider simply returns an existing object as the dependency. Here's an example of using a singleton provider to manage a database connection dependency. So here we import providers and containers from the dependency injector library. There's a class database with the init function which initializes the DB name, and if it is connected, which is initially set to false. If you call the connect function, it will set connected to true. If you call disconnected, it will set connected to false. There's an execute query function which executes a query on the database. It just prints it. This is just a placeholder. There's a class database container which inherits from containers.declarative container. Here you have the database name, which you get from the provider.configuration of database name, and the database equal to providers.singleton. This is a singleton container. What is a singleton? It's a provider, right? So it's a singleton provider where you pass in this database class and the DB name and as a database name thing. So in the main function, we have the container, which is initialized as the database container class, which we created here, and the database name is my database. So this is where you're providing the configuration, which is my database. So this database name is taken from this configuration. And there's a singleton provider, which is created with the database class and the DB name as the database name. So sure. So this is where it gets this from. So database equal to container.database, which it is this, which is a singleton provider. So what's a singleton provider supposed to do? It's supposed to create and return a single instance of a dependency, ensuring that subsequent calls to the provider return the same instance. Great. And result equal to database or execute query. So let's start from my table. So when you execute this, you should get this string query executed, query this one, executed on database, my database. And you should print the result and database.disconnect. So here you used a provider to get this whole dependency. So you did not have to manage connecting in here. Everything was managed by this container. So that's the benefit. So in this example, the singleton provider is used to create a single instance of the database class with the DB name argument set to the database name configuration value. This ensures we only create one instance of the database class throughout the lifecycle of the container. Providers are a key concept in dependency injection, and they provide a flexible and powerful mechanism for managing dependencies and their life cycles. For the rest of this article, dependency management with Flask, we will come back to them in the next part of this video. Thanks for watching, and please like and subscribe if you like this video and if you want to keep watching more design patterns in Python. Thank you.